Well, I want some national defense.
Permit me one last introduction of a man who really needs no introduction. In certain circles, he's known as the master of disaster, the Count of Monte Fisto, the King of Sting. This man's name strikes fear in the hearts of liberals. Let me introduce to you Dr. Craig Mitchell.
Well, that was truly interesting. I remember when I was in high school, I lettered in wrestling. And, you know, the name Craig Vincent Mitchell struck fear into the hearts of no one. So we're going to look at, is economic a science? You know, because what a lot of people would have you believe is that it is. And you know, when you watch television, what happens is, you know, they'll bring out some economist and he'll say, well, you know, in the fourth quarter, we think that this is going to happen, and this other, for this reason and that reason, the other reasons, this is what's going to happen. So you know, there's this almost like this Gnostic priesthood of economists. You know, and they understand all, and they know all, and they got it all figured out. And I remember after I got my master's degree in economics, and I started teaching economics at the University of Texas at Arlington. And I remember going to lunch with some of the other professors who used to be my professors, now I was their colleague. And one of the things I began to, you know, I just asked them some questions one time. We're having lunch, and I asked, so what do you guys think is going to happen to the euro the next year? And they all just sort of looked at me. And then one of them said, how the hell should I know? And what they explained to me is that there's two types of economists. There are the television economists who've got it all figured out. And then there's the real world economists who are a whole lot more humble about what they actually know and what they're capable of proving. Okay, there we go. So we got three parts of this: the nature of science, types of science, and economics as a social science. So let's look at what is science. Science is an empirical, inductive approach to knowledge. By empirical, what we mean is that knowledge comes primarily from sensory experience. You have to be able to see it, to taste it, to touch it, to feel it, to smell it. And by inductive, what we mean is a kind of logic that is based upon probability. Okay? Now, here's the thing about inductive logic. Can it provide certainty? It cannot. You know, it's one thing for me to say, the sun will rise tomorrow. Well, is that a logical thing for me to say? Yeah, it's a logical thing because that's what's happened for millennia. But do I actually know it? No, I don't. Because for all I know, you know, some asteroid could come sweeping along and just destroy the planet, or any kind of thing could happen that would prevent tomorrow from happening for this world and for the sun to rise and all of that sort of thing. So I don't know that. And that's the problem with induction. It cannot provide certainty. So here is what you have in the scientific method. You wind up with three basic steps, okay? You wind up with a hypothesis, which is an unproved theory or a proposition, that sort of thing. Then there's a theory, okay? One of the things that happens with a theory is you take that hypothesis and then you at least do some tests. And it passed those tests, okay? But you're still not quite sure. Then what you get to is a law, okay? And the thing about a law is this: a law is bulletproof. It's been tested in every possible way that we can test it, and it comes out the same every single time. Now, when you look at physics and chemistry and electrical engineering and a bunch of other things, you have theories and you have laws. Now, how do you get from a hypothesis to a theory? By testing. How do you get from a theory to a law? By testing. You can't move from the one to the other without actually testing. If you don't have hard empirical evidence as a result of testing, then all you've got is an opinion. So at each level, a hypothesis, a theory, a law, what you have is an increased degree of certainty. But complete certainty cannot be achieved because at the end of the day, what happens in science is you're still using induction. Francis Bacon wrote The Advancement of Learning, and he argued that scientific knowledge results from continuously experimenting. You have to be able to empirically gain a certain sort of knowledge, and then you use reason to evaluate it. But here are some problems that come with science. This is one idea: scientism. Some people believe that only science and the scientific method can provide any kind of knowledge. So what do you do with things like religion, with faith, or God? Well, if you hold to scientism, you just have to toss that stuff out. That's one of the problems. Positivism is similar to scientism, and it argues that science should be free of the influence of theology, metaphysics, and value if it will reflect true knowledge. Here's a very significant figure from the post-positivist physicalist movement, Wilfrid Sellars. He said that in the dimension of describing and explaining the world, science is the measure of all things, of what is, that it is, and what is not, that it is not. Okay, how many of you believe that? I hope nobody believes that. But you want to know something? There's a lot of very educated people who really do believe this. Nietzsche had a rather interesting view of the whole thing. His father, postmodernity, didn't believe that there is objective truth, morality, or meaning for that matter. And he believed that the world picture that physicists could construct differs in no essential way from the subjective world picture. And he believed that science is just another example of the will to power. Basically, I force my views upon you. It's not that science doesn't really produce truth. It just produces an opinion that others are willing to force upon you. So here's what happens with postmodernity. Postmoderns did not believe that there's such a thing as objective truth. They also believe that science is just another example of the will to power. Science cannot get to the truth because there is no truth. Okay, folks, when we say that the Bible is true, what do we mean? Here's what we mean. We mean that what you find in the Bible corresponds to reality. That there is an objective truth, and that truth can be known. Science points to no objective truth. The theory of relativity and the Heisenberg uncertainty principle are two examples of this, okay? Well, postmoderns point to these two things because, well, they kind of present problems. Here's what the theory of relativity says, that basically mass and dimensions and time, these things are constant until you start to approach the speed of light, in which case they all change relative to where you are. Now, all of this is the kind of stuff you can calculate kind of easily. But they took these ideas to say that because mass and energy and dimensions and time are all relative, that that morality and truth, those things are relative as well. Well, that's not what Einstein intended. They took these ideas far past what they should have. Okay, here's another one, the Heisenberg indeterminacy principle. It's about subatomic particles. You can know the position of a subatomic particle at any point in time, or its momentum. You just can't know both. And because of this, and some other ideas from quantum physics, they want to try to make the argument that everything is relative, that there is no objective truth. Now, the thing about the Heisenberg indeterminacy principle is this. It provides a very accurate statistical model about what happens with subatomic particles. Incredibly accurate. But to draw some of the conclusions that postmoderns do from it is a big mistake. So here's two views of science, okay? You have scientific realists who argue that science gets at the truth. And then you have scientific realists who believe that it really doesn't. And here are some reasons for scientific realism, okay? Number one, the success of science. You know, when I was a lieutenant, I worked for the Ballistic Missile Office. And we used to, the program I was in was the Reentry Systems Launch Program. We would go to Vandenberg Air Force Base, we'd take a ballistic missile, we'd put it in the hole, we'd put in experimental reentry vehicles, warheads, and we would launch to the Kwajalein Missile Range 4,000 miles away. And in the Kwajalein Missile Range, you got this lagoon, okay? At the Kwajalein Atoll, you got this huge lagoon, and in it we would put targets. And we would launch from Vandenberg Air Force Base, and in 30 minutes, less than 30 minutes, the reentry vehicle would come down at Mach 25, and it would hit those targets dead center. It's incredible what science is capable of doing. It's incredible just how well it works. And this is one of the reasons for scientific realism. Here's another one, mathematics. One of the reasons that we're capable of doing things like putting reentry vehicles on targets 4,000 miles away is because the mathematics works out incredibly well. How is it that numbers and mathematical theorems and the physical world all work together so incredibly well? This is one of the reasons for scientific realism. So they argue that science aims at the truth, and all of this, because it works so well together, it requires a kind of metaphysical realism. Karl Popper argued for scientific realism, was a big figure for it. He argued that science should be based on an empirical deductive method because deductive logic essentially argues that if you've got a major premise that's true and a minor premise that's true, then your conclusion, you can be sure that it's true as well. You can have certainty. So he believed that science should require deduction rather than induction. But here's the other thing. He argued that you have to have testing in order for something to be science. And so here's some of his other ideas. It's easy to find confirmation of the validity of theories. Confirmation should only be considered if it results in a risky prediction. The more a theory forbids, the better it is. A theory that is not possibly refutable is a poor theory. Genuine tests of theories are attempts to refute them, and the only good evidence is negative evidence, an unsuccessful attempt to refute a particular theory. He argued this. Look, he says science operates by the law of the jungle, the tooth and the claw. He says a theory is only as good as its last test. And when a theory fails a test, you know what you have to do? You have to scrap it. That's the kind of rigor and discipline that science requires. Okay, here are some arguments against science and scientific anti-realism. Problem of underdetermination. And so here's what it argues. You've got all this data out there. And you've got an endless number of theories that can explain that set of data. How do you know which theory is the right one? Well, you'd have to test them all, wouldn't you? Can you test them all? Well, probably not. Here's another position, instrumentalism. It argues that science does not get at the truth, but it is useful. You know, we look at cars, and we see them moving around. We don't know that there aren't hamsters that are making those engines turn, do we? I mean, yeah, we can explain all the stuff about gas engines and cylinders and all that sort of sparks plugs and all that sort of stuff, but we really don't know that that's the cause. That's the argument that they'll make. At the end of the day, they'll say, you know, science doesn't get at the truth, but it is useful. Here's something else, positivism. It's a rejection of metaphysical realism, and so in the end, it's kind of a refutation of even scientific realism. It's sort of a contradictory point. Some argue that there is no scientific method because of the inconsistency in its use. For example, the theory of relativity. You know what? We have tested the theory of relativity by looking at what happens with stars, what happens with black holes. We've tested it in 100 different ways. And you know what? Every single time, it turns out to be absolutely correct. Really, we should be calling it the law of relativity. let's look at another thing. Evolution. How do you test evolution? Have they ever actually tested evolution? No, you'll hear people talk about microevolution. Microevolution isn't really evolution. Has anyone ever seen one species turn into another? Has anybody? Well, the answer to that question is no. So really, the theory of evolution should be called the hypothesis of evolution. But they're inconsistent about the use of the scientific method, so that's a problem. David Hume was an anti-realist because of his famous argument against causation. Here's what he argues. You can know that one thing follows another thing, but you can't know that one thing causes another thing. He says you use induction to fill in the gaps. And you can't have certainty with induction because at the end of the day, it's based on probability. Thomas Kuhn wrote this book, The Structure of Scientific Revolutions. And he argued that science is really about power. And what he argues is that older scientists, they've risen to the top, and basically they've gotten there by supporting all of the ideas that they were taught before. But younger scientists have nothing to lose. So you know what they're willing to do? They're willing to test new ideas against those existing theories. And what happens over time is that they punch enough holes into the older theories so that eventually they give way, and what you have is a paradigm shift. And you wind up with new theories, new ideas. And so what he argues is science is not about knowledge, it's really all about power. Bastiaan von Frossen teaches at Princeton, and here's what he argues. He argues that science doesn't really aim at truth. It only aims at empirical adequacy. Now, here's my problem with that argument. I've known a lot of scientists over the years, and a lot of engineers over the years. They weren't interested in what was just adequate. Everyone I ever knew was trying to actually get at the truth. And here's something else that comes with science, okay? This whole question of value. One of the things that often happens is they go back to David Hume, who argued that for the fact-value dichotomy, that argues that there's no connection between facts and values because facts are judged by reason while values like morality and beauty are evaluated by emotions. And so a lot of people who are positivists will argue that science has nothing to do with values. Okay. Now, both of these guys, W.V.O. Quine, Ludwig Wittgenstein, they argued against the fact-value dichotomy in their own ways, and they both destroyed it. So here's what we see today, okay? The maxim that scientific knowledge is value-laden seems almost entrenched as its opposite was earlier. The supposed wall between fact and value has been breached, and philosophers of science seem quite at home with the thought that science and values may be closely intertwined after all. The scientific process requires that every scientist is fair, open-minded, and objective. Unfortunately, this isn't always the case. Good science requires that the scientific method be adhered to, which isn't always the case. And Thomas Kuhn explains normal science and the structure of scientific revolutions as a natural process of scientific change. Unfortunately, not everybody sticks to the rules of normal science. You have some people who argue for what's called post-normal science. It attempts to characterize a methodology of science that is appropriate for cases where facts are uncertain, values in dispute, stakes are high, and decisions urgent. And it suggests that it's all right to drop the scientific method when it's important to one's agenda. Okay. So here's what happens, okay? You have applied normal science here, but when things become, well, urgent and the level of uncertainty is high, they suggest that there comes a point in time where you can drop the normal rules of science and you can just, you can just sort of bend the rules. You know where one of the best examples of where this happens? Global warming. In fact, there are a number of guys who have written in favor of using this approach for science in global warming. Okay. Some scientific realists believe that if a scientific theory is true, it'll also be beautiful or beautifully simple. And some realists assume that the true, the good, and the beautiful are tied to metaphysics or metaphysical realism. But positivists argue that there's no connection between the true and the beautiful because they're metaphysical nominalists. Okay. Now let's look at the types of scientists. Okay. The major division in science was developed by this guy, Auguste Comte. Comte believed that the physical sciences had to come before the queen of science, or human society itself. And Comte's concept of positivism is a rejection of theology and philosophy so that science can be effective. And here is his division. You have science divided between the physical or the hard sciences or the social or soft sciences. Okay, the hard sciences are things like physics, chemistry, those sorts of things. And that's not really all that surprising. So you got biology, physics, chemistry. But here's the thing about the social sciences, politics, economics, law. Where do they come from? They come from moral philosophy. What Comte was interested in doing was cutting the ties of politics, economics, and law from moral philosophy. And not only moral philosophy, but moral theology as well. The social sciences come forth from moral philosophy and was influenced by the Industrial and French revolutions. And the intent of the social sciences was to develop systematic knowledge bases or prescriptive practices relating to the social improvement of society. And this starts happening in the 18th century. Let's just skip ahead and get to economics here. Economics is viewed as a social science that seeks to analyze and describe the production, distribution, and consumption of wealth.